This video is on dividing radical expressions. Recall that a radical expression contains a radical and that the expression underneath the radical sign is called the radicand. A radical expression is completely simplified if no radicands have perfect square factors other than 1, and we saw that in the previous video. No radicands contain fractions, and no radicals appear in the denominator of the fraction. To simplify radical expressions that contain fractions, we're going to use the quotient property of square roots, which says that the square root of the fraction a over b is equal to the square root of a over the square root of b. Let's take a look at a couple examples. First one says, simplify square root of 6 over square root of 27. So using the quotient property, I can rewrite that as the square root of 6 over the square root of 27. And then using the product property that we saw in the last video, I can rewrite the radicand as the product of its factors. And since I have a perfect square factor of 9 with the square root of 27, I'm going to write that. So here I have square root of 2 times the square root of 3 over the square root of 9 over the square root of 3. The square roots of 3 cancel. And on the top I have a square root of 2, and on the bottom the square root of 9 is 3. To remove a radical from the denominator of a fraction is called rationalizing the denominator. We are turning an irrational number, like the square root of 3, into a rational number, like 3. To do this, we want to multiply the numerator and the denominator of the original fraction by the radical in the denominator. Let's take a look at an example. So here we have the square root of 3 divided by the square root of 2, and I need to get rid of that square root of 2 in the denominator. So I'm going to multiply this fraction by square root of 2 over square root of 2, and I can do that because that's basically 1. I'm not changing the value of the fraction by multiplying it by 1. So on the top that's going to give me a square root of 6, which can't be simplified, and on the bottom the square root of 2 times the square root of 2 is just a 2, and so now I have a rational number in the denominator and my radical expression is simplified. Sometimes it's helpful to simplify the denominator first. So here we have square root of 6 plus 5 square root of 2 divided by 2 times the square root of 27. So I can't simplify anything on top, so I'm just going to rewrite that. But on the bottom, I'll have 2 times, actually I'm going to not write it in there yet. Square root of 27 is square root of 9 times the square root of 3. And then I have the 2 there. Square root of 9 is 3. So that's going to give me a 6 square root of 3 in the denominator. And the problem here is having that square root of 3 in the denominator, so I'm going to multiply the whole fraction by square root of 3 over square root of 3. That will rationalize my denominator. On the top, I want to distribute, so I want to do square root of 3 times square root of 6, which is going to give me the square root of 18. And then square root of 3 times 5 square root of 2. I can multiply my square roots, but not the number out front, so that's going to give me plus 5 square root of 6. And then on the bottom, I'm going to have 6 times square root of 3 times square root of 3 is 3, or an 18. But actually I can simplify this one step further because the square root of 18 is the square root of 9 times the square root of 2. So I can write that as 3 square root of 2 plus 5 square root of 6, and I can't combine those because the square roots, the radicals are different, over 18. And that is simplified. So here are a few problems I'd like you to do for practice. Stop the video and do these in your math journal. Okay, let's take a look at these examples here. First one is square root of 7 divided by the square root of 2. So I can't have a square root of 2 in the denominator, so I'm going to rationalize my denominator. And that's going to give me square root of 7 times square root of 2 is the square root of 14 divided by 2, and that is simplified. My second example here is 6 times the square root of 2 divided by 5 times the square root of 3. The problem is the square root of 3 in the denominator, so I'm going to multiply just by that. So on the top, that's going to give me a 6 square root of 6 divided by square root of 3 times square root of 3 is a 3, times 5 is 15. And I can actually simplify this a little bit further because I can cancel numbers that are not underneath the square root. So I can divide both the top and bottom by 3, and that's going to give me 2 square root of 6. Notice that does not affect the square root of 6 over 5, because 6 over 15 is the same as 2 over 5. And my last example here, negative 2 plus the square root of 3 divided by 2 times the square root of 7. So I'll multiply top and bottom by the square root of 7. And again, here I will distribute. So negative 2 times the square root of 7 is just negative 2 square root of 7. Square root of 7 times square root of 3 is the square root of 21. And that can't be simplified because 3 and 7 are both prime numbers. Divided by square root of 7 times square root of 7 is 7, times 2 gives me a 14. Now notice I can't do any canceling here with this negative 2 and this 14 because I'd need to have a number here in front of the square root of 21 as well. So if I had something like a 4 or a 6 here, then I could divide each of those by 2, but I can't do that, so this is my simplified answer. So in this video we took a look at how to divide rational expressions using the quotient property and how to rationalize the denominator.